Hey, welcome to the Explainer. Today we are diving into something that has probably caused you and pretty much every web developer a ton of headaches: cross-origin resource sharing. You know it as CORS. Yeah, if you're a web developer, I am sure you have seen this message pop up in your console. It's just the worst. But here's the twist. What if I told you that error isn't a bug at all? It's actually a super important security feature doing its job perfectly. Let's dig into why that is. So here's how we're going to tackle this. First, we'll look at the security risk that makes all of this necessary. Then we'll talk about the browser's big wall, the same origin policy. After that, we'll see how CORS acts like a secure handshake. We'll even get into the difference between simple and preflight requests. And finally, the part you've been waiting for, how to actually fix those frustrating CORS errors. Okay, so before we can really get why CORS is a feature, we have to understand the problem it solves. And trust me, it's a big one. Think about it. Your browser is this shared space where you have all these different tabs open. Without some strict rules, things would get chaotic and dangerous really fast. Let's paint a picture. Imagine you're logged into your online bank, mybank.com, in one tab. Everything seems fine, right? Your browser is holding on to those precious little session cookies, which are basically the digital key that tells the bank's server, yep, this is a legit authenticated user. Now, in another tab, you open up some other website. Let's call it malicious.com. It could look totally innocent. Maybe it's a cat photo gallery or a news article. But hidden away in the background, there's some nasty JavaScript just waiting to run. And this is where it gets really scary. That malicious code can secretly try to send a request to mybank.com from your browser. And because it's your browser, it helpfully and automatically attaches your login cookies for the bank. So, as far as the bank server is concerned, this request looks totally legit. It has no idea the request was actually started by that sketchy cat photo site. So, what could happen? Well, without any protection, that malicious site could do all sorts of damage. It could grab your bank balance, read your private messages, post stuff to your social media, maybe even try to reset your passwords or start transactions. This is the core problem, right? One bad website could potentially hijack your entire digital life. That's what we need to prevent. So, to stop this kind of chaos from ever happening, browsers have a built-in, super strict security rule. It's called the Same Origin Policy, or SOP. You can think of it as a giant default firewall that separates every single website you visit. Now, it's really important to understand what the browser considers an origin. It's not just the domain name like site.com. It's actually a combination of three specific parts: the scheme, which is the protocol like HTTP or HTTPS, the host, which is the domain itself, and the port number. For two URLs to be the same origin, all three of those pieces have to match exactly. And this table here, it shows you exactly how strict this policy is. Look, just having a different path doesn't matter. That's the same origin. But switch from HTTP to HTTPS, and boom, cross-origin. A different subdomain like api.site.com, that's a different host, so cross-origin. Even a different port number makes it a cross-origin request. In all those cases, the browser steps in and blocks it by default. Okay, so this same origin policy is awesome for security, but it's a little too strict for the modern web, right? I mean, what if you legitimately want your website on one domain to fetch data from your API on another subdomain? That's a super common setup. And that is exactly where CORS comes into play. It's not a bug blocking you. It's the secure, controlled gate in that wall, letting the good guys through. You can think of the whole CORS flow as kind of a polite conversation or a permission slip system. Here's how it works. Your browser sends a request and adds a special header that says, hey, I'm coming from this origin. The server on the other end gets that request, looks at the origin header, and asks itself, do I trust this domain? If the answer is yes, it sends back a response with its own special header. Access control allow origin. That header is basically the server telling the browser, yep, this origin is cool with me. You have my permission to share the data. The browser sees that, and only then does it let your code see the response. But wait, there's more. For an extra layer of safety, CORS actually handles requests in two different ways. There are what we call simple requests, and then there are the more complex ones, which are called preflighted requests. So, simple requests are pretty straightforward. Think of basic GET requests to fetch data, or a simple POST. They get sent directly. But for anything that might be more, let's say, dangerous, like a put, delete, or patch request that could change data, or if your request includes custom headers, like an authorization token, the browser gets a little more cautious. Before it sends the actual request, it sends a preliminary check first. It's called a preflight request, and it uses the options method. It's basically the browser asking the server, hey, just checking, is it okay if I send a delete request from this origin with these headers? And only after the server says yes does the browser send the real thing. All right, this is the moment you've all been waiting for. When you see that dreaded error message in your console, how do you actually fix it? Okay, if you remember one thing from this whole explainer, let it be this. The fix is always on the server, not the client. Let me say that again. You cannot fix a CORS error by changing your front-end JavaScript code. It's not possible. The permission has to come from the server that's hosting the data. So what does that server-side fix look like? Well, you need to configure your backend to send back that access control allow origin header we talked about. Luckily, most modern frameworks like Express or Spring Boot have packages or middleware that make this pretty simple. You can configure it to allow your specific front-end's domain, or if you're building a public API, you can use a wildcard to allow requests from anywhere. Just be careful with that one. You know, this brings up a super common point of confusion. You've probably been there. Your API call works perfectly in a tool like Postman, but the second you try it in your web app, you get a CORS error. Why? Well, it's simple. Postman isn't a browser. CORS is a security feature enforced by browsers to protect users who have multiple tabs and cookies flying around. Tools like Postman or a direct server-to-server call, they don't have that context, so the same origin policy and CORS just don't apply. So the big takeaway here is to change how you think about that error message. It's not a bug you need to squash, it's a security feature you need to understand and configure correctly. It's your browser doing its job, protecting its user, and it's simply waiting for you to tell your server which other websites it's allowed to talk to. So here's a thought to leave you with. Now that you know CORS is really a server-controlled security gate, how does that change the way you'll design your next API? When you know from the start that the server is the gatekeeper, you can build your applications to be both secure and cooperative right from day one. And that's our explainer on CORS. Thanks for watching.